Hey guys, welcome back. Today we're solving the problem merge k sorted lists. So we're given an array of k linked lists and each of the linked lists is sorted in ascending order. Our task is to merge all the linked lists into one and return it. If you're given three lists like we're shown here, the first idea that we might have is to initialize three different pointers at each head of each list so that we can determine which value is greater than the other one. When we compare each of the values of these different lists, we can see that 1 is the smallest value, 2 is the greatest value. So we can create another new node here starting with 1, and then we can proceed to initializing the next pointer for the next value. Now because we have chosen 1, both of these pointers will shift to the next value in the node, so we don't have to consider these ones anymore. The pointers will be here. Now we can repeat the same process again, comparing now 2, 3, and 4. Among these three values, which is the smallest? And clearly it's 2. So we can create a 2 here and we create a new node. Once you create a new node, we can shift this pointer again to the next position and we don't have to consider these 2 anymore. We can continue this process until we create a new list that starts with 1. It will be a merge of all these three linked lists. However, as you will notice, we will have gone through each of the linked lists individually until we create this new list that is fully merged and we can return it as our solution. The time complexity for this operation will be pretty large. It will be k multiplied by n because we will be having k number of lists and n will represent the length of the largest list, which can be one of these two. This is pretty efficient. However, there's a clever way of handling this solution that will yield a more effective algorithm. If we take the first two linked lists, we can repeat the process that we started earlier by initializing two different pointers at the start of each list and comparing the values at their head. If the values are the same, we can pick one of the values and create one of the lists as a node, and we can proceed with the same example as above. We can shift these two pointers to the next position in the linked list and we can compare the values at this exact position. Now it's clear here that the next value will be a 3. We can create the 3 and we will not have to look at it again. We can shift our pointer to the next value in the linked list. So we can compare the two values. We can take one of them, add it here. And as you can see clearly, we'll shift the last pointer to a 5 and we'll add the 5 here. Once the next pointer points to a null, we know we have to stop our entire process. With that said, we'll have combined the first two linked lists into one and we'll remain with only one other linked list to combine with the one that we have created. If we repeat the same process with the two lists that are remaining, you will clearly see that we will again initialize a pointer at the start of each of the nodes, and we will continue the process that we have done above here to merge these two lists into one. So the first value will be, we will compare the 1 and the 2, which are at the head, and clearly the 1 will come first. Once we've taken the 1, we don't have to look at it again. We can shift the pointer to the next node in this linked list. We can compare it with the first value in the second linked list, and clearly the 2 will be the first value that will be selected. Once we do this, we can eliminate the 2 and shift our pointer to the next node in this linked list. We will continue this process until we complete all these values in the linked lists. Once this is done, you can see that we will have merged all the k lists into one and they will be in a sorted order. So you can see we start from the least value all the way to the largest value. With this done, you can see that for every iteration that we do, we'll be dividing the number of lists by 2. So assuming k was 3 in this case, like for the first example, we will be dividing this list by 2 each time and merging the two lists that we generate. The time complexity for this approach will be O of n log k, and it is much more efficient compared to the first approach, which is n times k. With that said, let's code up the solution. The first thing we need to do is to check if the list is empty. If the list of linked list is empty, then we just simply return none. Otherwise, we continue with our algorithm. For this algorithm, I will define a merge function that will take the self, list1 and list2. The purpose of this function is to help us merge two different lists, and we can define it right away. Now, we'll define a dummy node, which will just represent a dummy linked list node. We'll also define a tail, which will initially start at the dummy point, For us to merge two lists, we will write a while loop, and this while loop will just check that both list 1 and list 2 are non-null. They both have some values, and our main condition will be if the list 1 dot value is less than list 2's value, then it means list 1 has the smallest value, as we discussed. So we can just append this value as the next node to the tail. And remember, we need to also shift list 1. So list 1 will be equal to list 1 dot next. Otherwise, this means the value at list 2 is smaller than the value at list 1. So what we need to do is to take the tail dot next to be equal to list 2. And we also need to shift list 2 to be equal to its next value. Whenever this while loop exits, list 1 or list 2 might have become null. And so we need to check if the other list contains some values. We can do this by just writing an if statement. So if list 1 has some values, then tail.next will be equal to list 1. If list 2 has some values, then we just need to make sure that the next of the tail will be equal to list 2. Once this is done, we can return the next value of the dummy node, because the next value will actually represent the node that has the first value taken from these two lists. With that out of the way, we can continue with our algorithm. This algorithm will be running while this list has at least one value. This is because we'll be merging all these lists into this given list. Here, I'll create a new list. I'll just call it L. I will write a for loop that will begin from the first index of the given list to the end of the list, and it will be incremented by 2 because we want to take a pair of lists each individual time. The first list in this linked list will be at position I. The second list, however, will be at position I plus 1. So if I plus 1 is still in range of this list, then we can return I plus 1. Otherwise, we'll return none. Once we have list 1 and list 2, it's simply a matter of merging them. So we can call self.merge, and we'll need to pass list 1 and list 2 to this function. However, we want to take whatever this function will return and add it to the internal list that we have created, which is represented by L. So we can just write L.append and append the return value of the merge function. Once each for loop is done, we can take the value of this list and set it to the L value that we'll have had, because this will represent the list with all the values that have been merged. Finally, the lists that we have will remain with only one value, and we can take that value and return it as our solution. Make sure to correct this. It's not less than, it's equal to 0. Another bug that you need to be keen with is at this point. Remember, we have these two conditions. If both of them are not met, that means that both list 1, the value at list 1 and list 2 are equal, but regardless, we need to update our tail. So our tail will be the tail.next. With that said, let's run the code and see if it works. And as you can see, this works and it's pretty efficient. If you enjoyed this video, subscribe to this channel for more content just like this one. Don't forget to like this video, and I will see you on the next one.